Okay folks, you wanted video of the Horton collaboration knives, so that's what I'll give you. It's about a 10-minute cycle cutting these parts, and these are already cut. So what I'm going to do is cut above the surface without the coolant on, so you can just watch the procedure, and I'm going to run it fast. So this is not going to be a 10-minute video. Anyhow, here we go. The first thing it does is come in and probe this cutting tool. This is the tool that cuts the track for the stop pin, and I want it to be very accurate. So every time I come in and measure the length, which I don't really need, that's not going to change, but what is important is the diameter of the tool can change as the tool wears, and that'd end up with the open and close position being off from one blade to the next, and I don't want that. So right now it's coming in, and it's going to touch that probe a couple times on this side, touch it a couple times on the other side, and set the diameter of that tool. And it's worn about 2/10 so far. I'm almost all done with these parts, at least with this operation. And the tool is worn a couple of tenths, which isn't a big deal in the grand scheme of things, but I have the capability of being accurate, so I'm going to be accurate. So now it's switching to the roughing tool. These parts are just water jet cut when they come in. Hang on, let me crank up the speed. These parts are just water jet cut, so I come in with a roughing tool and get rid of the bulk of the extra material that's on there. I'm running at about 400% right now. Normally this is running at 18 inches a minute. It's running about 70 inches a minute right now. So it cuts all the way around the perimeter of one, comes over to the other, cuts all the way around the perimeter on the other. Crank it up a little faster even. So it cuts the whole perimeter. Most of this isn't even strictly necessary. I mean, we could grind this stuff in by hand. The reason for this fixtures is to cut that track. It moves to a finishing tool now. So it does the same damn thing it did before. But with a sharper tool. So it's only actually removing like 0.02 on this one. This is just to give us nice, clean, machined edges. So it'll do this all the way around on the one, come back over, do it again on the second. Like I say, this cycle takes 10 minutes, but I get 4 blades out of it. So it's really only taking 2.5 minutes a knife. It's not a real big deal to do this and just up our accuracy level a little bit. But the important stuff that this program does is all coming up now. And what that is, let me turn the spindle down so it's quiet and up the feed rate. So what it's doing right now is cutting that slot. It just did a roughing pass. Now it's doing 2 finishing passes. It does that in each slot, and that's the reason I set that tool diameter before, is it's using cutter compensation here. So the machine knows what the diameter of this tool is, and I've told it what I want the profile of this slot to look like, and it adjusts for it. So if the tool is bigger or smaller, I switch tools, anything like that, they end up all the same because it's compensating for the variations in the diameter. So there we go. I just did this real quickly because, like I say, that's normally a 10-minute cycle, but that's it. That's the first operation here. And you end up with a nicely cut slot. The perimeter's all done. I'll come through now and cut these tabs off and separate the blades. But the whole reason for doing this way is you need at least 2 points to locate something. So rather than have 2 points on each blade and have to cut this off, it's wasteful on material. I have these blades tip to tip. They locate on this spot and this spot on my fixture, and then this just holds the center down. But by locating them positively, rotationally, I can now do this slot, and the slot is the same on every blade. Anyhow, that's it. There you go.